Exercise 403 is about this concept called an annuity. Now, like I said in class, I think annuities will be a new concept for most of you. So what makes it new and different? The thing is, an annuity is based on a regular deposit being made into an investment account, a regular deposit. So unlike when we had our compound interest formula and one principal amount was invested, here we've got lots of little smaller amounts usually being deposited. So an annuity is an investment where you make regular contribution or deposit every period for an agreed time. Every period, what might that be? It could be weeks. It commonly is months. It could be half yearly, quarter yearly, yearly. And for an agreed time, that could be, well, if it's monthly, it might be 5 years, over 5 years. You're going to deposit an agreed amount every month for 5 years. So it's a really good way to save money because we can afford these smaller deposits. We have committed to putting that aside, and it's like a forced saving. Superannuation is a good example. Christmas clubs are good examples. And savings accounts like sinking funds are also examples. So if you see any of those words, you need to make the connection directly to an annuity. Please make note of these names. The contribution is a set amount and it's usually paid at the end of the agreed time. So you can see here we have $100 being deposited at the end of whatever the one agreed time is. It will earn interest all the way through. That first deposit you make earns interest. There is another deposit of, say, $100, and it's going to earn interest. So, second deposit, it earns interest and interest for as long as it sits there. Third deposit's going to earn interest. Fourth deposit, it would also earn interest. Now, you can probably see that's getting very complicated because the time that this first $100 sits there is different to the time this $100 sits there, and so on. The calculation is quite complicated to find out how much money you have in the end. So, because of that, we usually use a table where values have already been worked out for us. But let's have a look at this. So, at the first period, the interest rate per period is, so we read across, is going to be 10%, and the contribution per period is $100. This here now tells us the balance at the start of the period, the interest earned, the amount you've got then at the end of the period, and the balance at the end of the period. So when your first $100 is not being deposited until the end, hasn't had time to earn anything, it's still $100. Second period, you've got $100 sitting there. It's going to earn $10 worth of interest. Another contribution is being made at the end of the period. So now we've got all of these, what we had at the beginning, its interest, and a new deposit, which makes $210. Now we've got $210 sitting there. The interest being earned is $21. At the end, another deposit of $10 is made. So at the end, we've got what we had at the beginning, plus the interest, plus another deposit, which is $331. Carries over for the beginning of the next period. New amount of interest being earned, another deposit, and when we add up all three of those, we get $464. I won't go any further, but I will show you what the those balances look like in a graph. So you can see, not a straight line, it's going to rise very quickly. It's rising very quickly. And that's the feature of this type of saving, and that's why people invest in an annuity. Let's have a look at this example. In this example, the table shows the progress of an annuity over 5 years. This contribution is only $600 per year, made at the end of the year, and the interest rate is 3% per annum. You really must be prepared for all variations. The amount of money deposited will vary. When it's deposited will vary. The rate will vary. So you've got to read the questions very carefully and note those features. In this table you can see the balance was 0 for a whole year, no interest. At the end of the year, $600 was deposited, but that's all there is. Just doesn't have any time to earn interest. Becomes the balance for the second year. $18 of interest is earned, and we could talk more about how they calculate that. You simply use I equals PRM. Whoops. You can then see the three amounts, the balance at the beginning, the interest and the new deposit have all been added together to give the balance at the end of the year to be $1,218. Balance at the beginning of the third year is entered there, interest is calculated on that amount, a new deposit made, and we have to calculate the amount that would be in that account at the end. So just like you can see has been happening previously, to get A, we need to add 1,218, the interest that was calculated nicely for you, another $600, and you get $1,854.54. So B becomes that exact amount as well, $1,854.54. Now, C is a calculation of interest. We're going to use the formula I equals PRN. So based on the amount that is in the account at 3% per year, write it as a decimal, 1 year becomes $55.64. You could then check that if you add $600 on to your amount for B, your interest for C, plus another $600 gives you the $2,510. So to answer B, we need to bring forward the balance from the end of the 5th year, and so we've got $3,185.49. It's going to earn interest, same rate, which gives $95.56. Remember, another deposit will take place at the end of the 6th year, and when we total up these three amounts, we get $3,881.05. In Part C, it says if the contribution made at the end of each year is doubled to doubled the 600 to 1,200, what's the balance at the end of the 4th year? All we simply need to do is to take that amount that is currently at the end of the 4th year and double it. So your answer for C is $5,020.36, simply doubling the amount that's there. Now, it probably comes as no surprise that an annuity achieves an increased amount in an account very quickly, and it enables you to start an investment even though you may only have a small amount of money to invest. calculating the future value of an amount, you can see, becomes quite complicated. So if we were doing this for an extended number of periods, that would require a lot of calculations. So you will rarely be asked to do that. Instead, you'll be presented with a table where all the complicated process has been worked out for you. Now, in that table, you will need to be very, very careful, because just like we have to be flexible with the information that's given, we have to be very flexible with the way a table is presented. There are, again, could be variations to what the numbers in the table actually represent. I just strongly encourage you to read the information about the table many times. Don't expect that one read through and you'll be able to understand the table. Expect to have to read many times. If you look at this example we've got here, it's going to give me the future value. Interest factor is just a number I'm going to take and multiply. So it's talking about the future value. Now, it's the future value of an annuity with a contribution of $1. You might think that's unusual and probably not very realistic, and that's true. So what we will do, however, is it's still a valuable table, because we will just be multiplying the entries out of the table by the value of our deposit. So we won't be depositing $1, we may deposit 50, so we would take a value out of the table, multiply it by 50. You can see the table is made up of periods 1 through to 12. They could be years, they could be months. Interest rates of 0.25%, etc. Now these are still percentages, they haven't been converted to decimals. The rate in the table is given as a percentage in this current table. That may change in the next table. So how do I know it's a percentage? Well, I look carefully and I can see the percentage sign is still there. These values look like decimals, however, they're not the decimal equivalent of a rate. So you can see that 8.5830 has been circled. What would we know about that number? What we know is that $1 turns into $8.58 when the interest rate for the period is 2% and $1 is left there for 8 periods. Let's have a look at this example based on that table. Dominic opens an account that earns interest at 3% per annum compounded monthly. He contributes $100, so it's not $1, it's $100 for 6 months. Now, there's a little bit of work that needs to be done. 3% per annum compounded monthly. Now remember, this is the interest rate per period. The period is months, and 3% per month is, we can leave the percentage sign on, but you must divide by 12. So your rate is, that's 1/4, 0.25% per month. So we're going to look down this first column. His investment's going to sit there for 6 months, and so it is this value here that we want. So the amount, the future value is going to be $100 times 6.0376, which is $603.76. To calculate B requires quite a bit of work. We don't have a formula. We have to use our understanding. How much interest will he earn? In this case, interest is the difference between the future value and the amount deposited. So we know the future value. His future value is $603.76. We have to think about how to get the amount deposited. We know that he was depositing $100 for 6 months. He's deposited $600. So his interest is $3.76.